Hi everyone. In this lecture, we will discuss about the some of the examples as well as some essential as well as essential primary implicants and about the grouping details we will look into in this. Already I have done a video on the basics of the K-map. So here let me take an example like given the terms, minterms are given and it is already mapped into the K-map, and make a note that we are following the gray code sequence and 2 comes over here and this will be 3. In the same way, 8 comes over here, then 9, 10, 11, 12, 13, 14, 15. In that way, we have to keep that in mind always so that we will be getting the proper simplified form. Now, check that is this 4 are, we can group it together and we can say it is in the adjacent cell. And the same way, these 4, the ones in the corner of this K-map, all 4 are, we call it as in the, we say that those are in the adjacent. So we can group it together. So the equation for this is BD, and after grouping this 4, see we can check in this 2 row what is common. Over here it is B bar, isn't it? In this 2 column what is common? D bar. So the equation for grouping of all 4 corner ones is B bar D bar. So these are the, we can say that prime implicants. Each combination we get from this grouping, those we can call it as prime implicants. So these 2 are essential prime implicants of this particular graph. Now coming to this. So in this we can see extra grouping over here, isn't it? So this 4 can be grouped, make a group of 1. This 4 you can make a group of 1 to include this one. So otherwise it will be it can also be included along with this group, and to include this corner 4 ones we can go, but check which is essential over here so that it covers all the ones in one or the other particular group. So let me group this first, and to consider this to 1, I can make a group of this 4, and then this 4 can be grouped, and the only one thing remaining is this and this one. So to include this one, I can group all the corner ones. So prime implicants. So here they didn't group in this K-map. They didn't group all. So we can make that. That is the right way of grouping. And here they have grouped like this 4 ones and this 4 ones. So from this what we can understand, those are all prime implicants, but still we need some more groups to cover this one and this one, isn't it? By looking into this graph, we can make out that. So from that, we should come to the conclusion by looking into graph, which is the essential prime implicants. See, if I group this 4 together also, I need to group this, isn't it? Otherwise, this one will not be covered. So for that purpose, I can say that this group is an essential, very essential group over here. this one is not needed because these two ones are already included in this group, and in the same way these two ones will be included in this group, isn't it? And these two ones are included in this group. So this grouping is not necessary over here. In the same way, this grouping of these four ones also, it is not essential over here because this one is already included here and these two ones are included in this group, and this one is already included over this group because we need to so this grouping is not required, and this grouping is also not required, I guess, because this one will be included in the grouping of this corner ones. Hope you understood. So that grouping of this one is also not required. So in that way, we have to make the wise decisions and make sure that we choose an essential groups. So avoid redundancy so that we get the minimized expression. And one more thing I need to tell you that it will be having more than one solutions depending upon the groups you select. Your answer may vary. So here is the another example. It is the function f of a b c d equal to summation m 0, 1, 4, 8, 9, 12, 14, 15 is given. So map that into the K-map. Draw the K-map. That is, it is having 4 literals. That means 4 variable K-map is needed. So draw that and map this minterms into the K-map. And once you completed all this, now try to group by yourself so that you can practice and be familiar with the K-map. So first what we need to check whether any 8 ones or 16 ones are there. 16 ones it is not there in this K-map. 8 ones also I cannot see anywhere, isn't it? So we have next we have to go for 4 ones together. So here I can find the 4 ones together. So I can group it as group 1. And another 4 ones, is there any together? See here one it is there. And so I can group like this, 4 ones together. And the remaining is these 2 ones, so I can group it together. So if I group 4 number of ones in a 4 variable K-map, then how many literals will be there in the equation of the group? It will be having only 2 literals. So this you have to keep it in mind so that your equation will not your combination for the particular group will not go wrong. So for this another, so how to get that? See, check this row and this row. What is common over here? That is B bar is common. This column and this column C bar is common. So for this group it is B bar, C bar. And for this it is 2 number of ones. It will be having 3 literals. So check it out. What is common? So this row is common for both. So A and B is common. And in column wise it is C. So ABC is the equation for this group. So what will be the final equation? F equal to ABC plus C bar D bar plus B bar C bar. Hope you are following. Now we studied how to map or how to group normal K-maps. Now we will discuss about the don't care condition. What does this don't care condition means? See, just don't care it. If you like don't care, in some cases they notate it as D, some cases it is phi. Both can be notated, and the meaning is if needed you can include in the group, or else you doesn't bother about that. So let us see an example. It is the three variable K-map, and the function is given f of ABC, which is equal to summation m 0, 1, 5, 7 plus 5 of 2, 4. This represents the don't care condition. So here I can show you that it is marked as 5 for 2, which is 2, 0, 1, 0. This is the 0, 1, 2, 3, isn't it? So this is marked as 5, and 4 it is over here. It is marked as 5. Rest 0, 1, 5, 7 is 1. 0, 1, 5 and 7 is 1. Now we need to group. So check for 4 ones together. So I can say this one is one group. So here in this case, I consider this 5 as 1 and include in this group, so that I can group a 4 ones together, so that my expression minimizes. And next is this one is remaining. So to include that, I have to group like this. So this will be the minimized Boolean equation for the given function f equal to b bar plus ac. B bar is the equation for this group of 4 ones, and in the same way, for this it will be having a as well as c. See, in this row it is common for 2 ones, a is common, and in the column wise it is c. Hope you are following this. Next, let me check don't care condition for 4 variable K-map. So here the question is given, and here I have notated as summation d. That means don't care. That is should be marked in the 0, 2 and 4. See, check. Either I can mark it as 5 or x. Here 0 it is don't care, 2 don't care, and 4 it is don't care. Now check how we can group. First you have to go for 16 ones, then 8 ones. 8 ones is not there anywhere. Now next is 4 ones. Yeah, there are 4 ones, isn't it? I can consider this as 1, and I can make a group over here, and the same way 4 ones are here also in this column. So I can group like this. So if I group all these 4 ones, I can consider this x as 1 and include in my group. That is the advantages of using don't care. You can either include or neglect. It depends upon choosing of your group. So expression for this group it is a bar, b bar, and this is for this it is cd. Now this is just an information. For one variable K-map, it will be having 2 raised to 1, 2 cells. For 2 variable K-map, it will be having 2 raised to 2, 4 cells. In group, 2 number of ones. In a group, if you have 2 number of ones, then equation has 1 literals. In the 3 variable K-map, 2 raised to 3 means 8 cells will be having. So in a group, if you have 2 number of ones, then the equation has 2 literals. If it is having 4 number of ones, then equation has only 1 literal. If 8 number of 1, then we can say complete equation will be equal to 1. Next, 4 variables. 4 variables means 2 raised to 4. That is 16 cells it will be having. So if you have 2 number of ones in a group, then the equation will be having 3 literals. 4 number of ones means equation has 2 literals. 8 number of ones means only 1 literal will be having in the equation. The same way, all the 16 cells are once means it will the complete equation will be equal to 1. Minimized form will be equal to form 1. So here we will be discussing about the SOP as well as POS. So check out an example over here, and f of ABC, f equal to a bar b c bar plus a b c bar plus ABC using sum of minterms and maxterms. So let me choose here minterms. For SOP, what is the difference? In case of SOP, I'll be highlighting with 1, and for POS, I'll be highlighting with zeros. So here A bar means this row, B bar it is this. So this, in the same way, I need to map this also. A B C bar, A B C bar. Sorry, here they have chosen AB as this one and C over here. So it is A bar B, A bar B, it is A bar B and C bar. So this one. Next is AB. AB means this column and C bar means this row. This one. Next is ABC. That is this column and this row. So it is one here. So this two can be grouped together and this two can be grouped together. That is B, C bar, and this is, for this it is AB. Now, once we mapped this in SOP, rest of the thing will be filled with 0, isn't it? So for POS, we can directly get it from there itself. Now we need to group zeros. See, we can group this two together. So it makes 4 zeros together, and this 2 zeros together, it makes another group. For this 4 zeros together, I can write the equation as, what is common? See, in this row wise, nothing is common. In column wise, what is common? B bar is common. So I can write F bar equal to B bar. The equation for this, here C is common, and in column wise, A bar is common. So B bar plus A bar C, or else I can write in terms of POS, on POS itself, I will be getting B in this, from this group. So B, in case of POS, I should be using product, isn't it? Instead of plus, it will be multiplication. Dot, I can say it is a dot. So I'll use the bracket, and the next literal for this is common is C, as well as A. C means we have to write it as C complement, and A is A itself. So here it is B bar. Because of that, I have written it as B, and A plus C bar, which will be equal to F. That is in case of POS. Example. So the function is given. Map that into the K map, that is 2, 3, 4, 5, 7, 8, 10, 13, 15. So once we mapped, check for the number of ones. See, this 4 can be grouped together, and this one is remaining. So I need to group with this one only. So it is grouped over there. Next, These two ones can be grouped together and these two ones can be grouped together. See, for understanding purpose, I can say you this group which is not needed. So rest all are essential prime implicants, and this group we can call it as redundant group over here because which is not needed already. This one is very essential because to cover this one we need to group this one, and this one will be covered in this group. So if we group this one, entire simplification or the final answer will go wrong. So such groups we call it as redundant groups over there. See, it is clearly mentioned over in this example. See, we have already chosen this group and this group and this one and this one. If we group this group, we call it as redundant group because both the ones are already included in one or the other group. So in such case, we call this group as redundant group. But this is not a redundant group because this one is not included in any of the other group. And to group it with some or one or the other one, we choose this cell as adjacent cell and we group with this one. Okay, so this is not redundant, but this group is redundant one. Hope you are following. One more example in case of three variable K map, that is in case of POS, here we have to mark with 0. Sorry, the given equation is given in terms of SOP, and this is SOP and this is POS. So SOP, this one I have to mark with 1. See, 1, 3 and 5. So here I have chosen A and B, C this way. So it is left up to you. How you are comfortable with, you can use 0, 1, 0, 0. So when you choose this method, then your cell number changes 0, 1, 2, 3, 4, 5, 6, 7. It becomes. So make sure follow any one method. 1, 3, 5. That is 1, 3, 5. And rest all it will be 0. That is 0. 2 it is 0. 4 it is 0. 6 and 7 it is 0. In this way we can map. See here I have an example that it will be having more than one solution. So f equal to summation 0, 1, 2, 5, 6, 7. So here 0, 1, 2, 5, 6, 7. All those are marked with ones. And here you can group either like this or in this manner. See here, in both the cases, you don't have any redundancy, isn't it? All are essential, and the same way, both answers are correct. We cannot say it is wrong and this is correct. We cannot judge anywhere. Both answers are right. Now, taking one more example in case of POS. See here the function is given. Always POS we will be notating with pi of m 0, 2, 3, 6, 8, 9, 12, 13, 15. When we are given this maxterms, we have to mark it with 0. So 0 it will be 0, 2 it will be 0, 3, 6, then 8, 9, 12, 13, 15 will be 0. Now we have to group it check for 4 zeros together. Here we have 4 zeros together. Now writing the equation for that. What is common over here? That is A is common. 1 is common. In this case, I have to notate it with A bar because it is POS. And the same way in column wise. Column wise, what is common? That is C. 0 is common. Then it is C. Next, in these two cases, here I have grouped so here in this case, so what will be the equation? So common is AB here, then AB is common here, and in column wise what is D? So if it is AB, we have to write it as A bar plus B bar, and in case of column it is D bar. So A bar plus B bar plus D bar will be the equation for this. And the same way, next group, check it out. Which one? So I have to include this 0 in the group. For that purpose, I have to group like this. So what will be the equation? Now B is B bar is 0 is common. So I have to notate it as B, and in case of column wise CD 0 is common. So I have to notate it B plus C plus D for this group. And for this, now this I can make this as one group and this as one group. So for this, what is common? 0 is common in row, and in column C 1 is common. So I have to write the equation as for 0 it is A plus B plus C bar will be the equation. And for this, what will be the equation? 1 0 is common for both the zeros. 1 0 means it is C bar plus D plus what is common over here, it is A. A plus C bar plus D will be the equation for this group. So hope you can understand the equation of particular group by identifying the colors over here. So in this way, I can write the final simplified form of the given POS or given maxterms boolean function. It is B plus C plus D dot A plus B plus C bar dot A plus C bar plus D dot A bar plus B bar plus D bar dot A bar plus C will be the minimized form. In the same way, one more example. So, given the it is summation because we use only pi for POS. Here it is the K-map for SOP. So f of ABCD equal to summation m of 0, 2, 3, 6, 7, 8, 10, 12, 13. So all those I have mapped into the K-map, and now how to group. So all the corner 4 ones I will group it together, and this 4 ones I will group together. The remaining is these two. So for this common term in row wise, that is AB is common, column wise C bar is common. So AB C bar, and next in the corner wise, check in the row wise what is common. That is B bar is common, and in the column wise D bar. So plus D bar D bar. Next for this 4 1, what is common? That is A bar is common, and in column wise it is C is common. So this will be the minimized equation for the given function. or this is the one method, or f of a b c d equal to summation, it is given over there, isn't it? In the previous case, ones are marked over here. Now, how to get a POS from this? So, mark the zeros over leftover places. Mark the zeros with leftover places in the K map and then group that together. So, we will get the POS. Either choose, so I have marked all the leftover places with zeros and later made a group. So first this 4 can be grouped together. So what it will be the equation? So it will be common is A C bar, and for this equation is ABD, and for this equation will be A bar B bar C, and for this group the equation will be B C bar D. So we got the equation F bar. Make a note that here in case of POS we will be always getting the equation in the complemented form. So F bar equal to, if we are grouping and writing it directly in the SOP form, then we have to notate it as F bar. So to get F equal to, we have to complement it. Obtained equation, we have to complement by using demorgan's theorem. We have to apply a complement on this. So after complementing, whole complement. So this is the F bar, and whole, apply the whole complement using demorgan's theorem. If you have the whole complement, a plus b whole bar equal to a bar plus a bar dot b bar, and a dot b whole bar equal to a bar plus b bar. So according to that, I can split my complement. So instead of plus, it will be dot over here, and here it will be dot. For this, it will be dot over here, and individual complements. Whole complement is split into individual complements, and later again apply into the bracket, that is applying to the individuals. See, here we have dots, so it changes to plus when you apply it individually according to De Morgan's. So this will be the final equation for F. So if what we understood from this, if we use zero in case of POS, if we group zeros and write the equation in S of P, then we will be getting in the F complement form, and we need to apply De Morgan's theorem and clear it. Simplify those to get the uncomplemented form or minimized form of the given boolean function. So this is the one method, or else when you are writing, you can directly write it as from the here itself, you can directly write it in the POS form. That is another method. Now here, one more example. I just want to show you that is a grouping. So this can be grouped. Here we cannot group 4 ones together. This is left vacant. So we need to. Is there any other choose? Is there any other method to group? Yeah, you can even group this 2 1 together, this 2 1 together, and this 2 ones together. So it has one more solution also. So both are correct, but don't choose this group. This is the redundant group. Once you group like this, if you are grouping again like this, it is a redundant. This both will be redundant. And if you choose this also, after grouping in this way, if you choose this as another group, then it will be considered as the redundant. So this is the example for don't care. So we can, this one it is not required, so it is not used. And if we consider this don't care, I can make a group of 4 ones together so that my equation reduces to C. Using don't care condition, one more. So here, see here, so many don't cares are there. All those are, so if I you choose all these don't cares as one, then I can group as 8 ones together. In case of 4 variables, 8 ones together means we'll be having only one literals in the equation of the group. So here another example is given. So this 4 can be grouped, make it as 4 ones. I can choose this don't care. And this one corner 4 ones I can group together. So I can make use of this don't care. And this one is remaining, isn't it? So to make that one, include that one in a group, I can choose this don't care also. So here all the don't cares are used or included in one or the other groups. So this will be the minimized expression for the given boolean function. One more example of don't care. You can refer this. All those things I have already explained, and if any queries, just comment me. See here, in this case, this one is independent. It cannot be grouped in any grouped along with any other ones. We don't have any ones in the adjacent column, so it should be grouped as independent. So when it is grouped as independent, it will be having 4 literals in the equation. So refer my blog, Explore Electronics, for the notes as well as PPTs. Please subscribe my channel. Thank you.